Hey everyone, my name is Ajay and this is part 8. And in this section, we are going to discuss about the OMP, which is Overlay Management Protocol, and SD-WAN data plane. About OMP peering. So OMP is a protocol which is responsible for exchanging the routes. So there's a term OMP peering, and this OMP peering, it is going to run between the V edges to vSmart. So we can see on our screen, there's a first peering. The second pairing is going to be to the second vSmart. Similarly, the case with another VH. It is going to have two OMP pairing to two vSmart. And the same OMP pairing is also going to be there between the vSmarts. So if you have multiple vSmarts in your network, they are going to run the OMP pairing in full mesh way. So we all know there is a DTLS tunnel what we establish between the edge device and the vSmart. After having those DTLS established, it is going to establish a OMP pairing. So it is on by default. We are going to explain this whole scenario and we will also take a look on the different output to understand how exactly the OMP works. The first thing would get exchanged over the OMP peer is going to be your TLOC routes. So TLOC routes, it means let's assume you have multiple VHs and you are going to have those physical attachment where you are having a connectivity to your service provider. It can be internet, it can be MPLS, and rest of the network. They are also supposed to know how many connectors or the attachments you have throughout the network. So this is going to be the first type of OMP routes, which contains the information about the TLOC. And that information goes along with these attributes. The first attribute is going to be the site ID, since we know every site is going to have the unique ID within the network. Then encapsulation SPI, encap authentication type, encap encryption, what is the public IP address versus the private IP address, and similarly the public port versus the private port. If you are doing some sort of the NATing and all those things comes into the picture. Then it is also going to show you the status for the BFT, which is going to be bidirectional forwarding. So it's a kind of the probe which gives you the health check for the path. Then you will have the tag, preference, and bait. Preference and bait, that is something can be configured on a particular interface. So if you want to change this information, you need to go to that VPN interface and change these values. After having the TLOC table populated, basically the TLOC routes, we need to learn the routes. Those are part of the service VPN. So service VPN is going to be your LAN site. Those routes can be connected, can be static, or they might be coming from dynamic routing protocol like OSPF, BGP, or EIGRP. So these routes also goes to vSmart as a OMP update, and then vSmart is going further distributed to rest of the world. When I say rest of the world, those are going to be the different VHs participating in your network. So these routes also goes along with some attributes. The first attribute is going to be the TLOC. It is going to tell you which is the TLOC is advertising this route. Then the site ID, label, VPN ID, tag, preference, originator, system IP, origin protocol, and what is going to be the origin metric. Let's take a look from VH point how the pairing looks like. So if I run a command which is going to be the show OMP pair, it is going to tell you there are two pairing exist to two different vSmarts, and the site ID is different. So as we discussed earlier, every controller and every edge device, they are going to have a different site ID. So we see the first vSmart is having the site ID 52, the second vSmart is having the site ID, which is going to be the 53. My current status for this OMP pairing is up. This is the uptime, which is 2 minutes 45 seconds. And I see RIS. That means how many routes I have received. So receiving route is going to be 7272, which should be same. And now I see a small difference. The installed route, it is coming from 52, only those are getting installed. And the routes which is coming from 53, those are not getting installed. And the reason, the route is always preferred due to as having a lower system ID, system IP basically. So in this case, 52 is going to be the lower system IP. Hence, all the routes coming from vSmart, which is going to be 52, are going to be installed. In case this fails, the route received from 53, they will get installed. So OMP pairing, whenever this pairing established, it happens after all that DTLS channel is established. And this pairing happens over the system IP address. You might have multiple connections to vSmart, but you are going to have only one OMP session running. Now let's take a look on how the TLOC route advertisement look like. So TLOC routes, they are going to contain your TLOC private IP address, your public IP address, your carrier identification, your color, encapsulation type, preference, site ID, tag, and weight. So let's take a look how the outcome looks like. If I run a command show OMP TLOCs on a VS device, it is going to identify different fields. So now the first field looks like TLOC IP address. So this TLOC IP address is going to be the system ID. Who is advertising all those attachments to you? So I see there are two entries. So my first entry comes from one vSmart, second entry comes from second vSmart. So I can see this is a CIR. So this is a valid entry, and the route received from 52 are going to be get installed. My color identification is MPLS. My encapsulation type is IPsec. And my public IP address here, I can see 192.168.0.21. And my private IP address is 198.1.19.1.2. Since my public IP address and private IP addresses are different, that means I'm doing some sort of the NATing in between. So since this is MPLS, so this is something what is expected. My public IP address is going to be the discovered public IP address. So when we take a look on the configuration of MPLS on that particular interface, then I'm going to see this private IP address that is going to be something configured on interface, and my public IP address is going to be the discovered IP address. Very similarly, if I take a look on the public internet, I can see my public IP address and my private IP addresses, they both are same. That tells you that this is the static public IP address which is being used on an interface which is configured with the color public internet. Now we see there's a port, public port and the private port. And I'm not using the IPv6, so I don't see any entry. And at last, I see the VFD station is going to be the up. You can also build a network topology based on the TLOC routing table, which tells you about the whole topology, how many TLOC attachments you have. So on a previous output, what we have seen, I translated that into a topology while identifying only two VHs. Now my first VH is BR3, VH1. It is going to have a system IP which is 192.168.0.18.81. On the colo side, my first VH is going to have the IP 192.168.0.80. Here I can see I have a two attachment. One is for the MPLS, one is for the internet. My private IP address and my public IP address, they are different. It means I'm doing some sort of NAT in between. Very similar case here. I see my private IP address 192.192.2 and my public IP address is different. So that is something expected behavior. When I see my public IP address and private IP addresses are same, that tells you are using a static IP address on the interface. Very similar case on other side as well. Let's verify how we can verify this. So you need to run a command show interface description. I can see 81 is my system IP address. 19.5.2, it is going to be my MPLS, and 5.200, that is going to be my internet IP address. Very similar on the CL2 VH device, I can see 192.168.0.80, that is going to be the system IP address. 18.2.2, that is my internet, and 19.2.2, that is going to be my MPLS attachment. So whatever the outcomes we have seen previously, this is the same as expected. We can also see it's a similar topology what I have. So this is my branch 3 edge 1, which has one MPLS and one internet attachment. Very similarly on the co-location side, I have CL2 edge 1 device, and I also have two connectivity. One is for the internet and one is for the MPLS. So it's matching what we have verified with TLOC routing table. After building the TLOC route table, there's a second update which we call the OMP routes, V routes. That is going to be the routes learned from the service VPN. So those are going to have some attributes as well. The first attribute is going to be the TLOC, origin, originator, preference, service, site ID, tag, and the VPN. As we can see, the origin is something, the source of the route, and the metric associated with original route. Originator, the IP address from which the routes were learned. Preference, we already talked about, that is something you can set under the interface. Services, the network services associated with the OMP routes. Site ID, we know every site is going to have the unique identification. Tags are something optional, and VPN ID is going to be the network segment number. You might have one on the LAN side, you might have multiple based on your LAN topology. Let's take a look on the OMP routes, V routes exactly, and those are learned from the service VPN. To verify the routing table, you need to run a command show OMP routes received. You can also run the same command with show OMP routes advertised, or without any keyword show OMP routes. So if you run show OMP, just the show OMP routes, it is going to show you other routes learned and advertised as well. When you see received, it is going to tell you how many routes are received. And when you are going to replace received with the advertisement, it is going to tell you how many routes you're advertising from this VS device. If I take a look on the routes, which is coming from 81, that is a branch site which we discussed in our topology. So I see the branch site LAN is a part of VPN 10, and I'm receiving a route which is 10.224.2.0/24. and it is coming from two different vSmart. So only routes from one vSmart are going to be installed, and the second remain standby. So I see route from 52 are getting installed here. That's the reason you see the CIR. And then we see what is the system IP address, what is the originator, and then we see the TLOC attachment. My first TLOC attachment is public internet, second is MPLS, the encryption type is IPsec, and I don't see any preference. That means it's going to do ECMP. You also have option if you want to grab any specific route, you can go for the include command, and the include command can contain any of these fields basically. Here on my screenshot, you can see I included with the route, and I also included with a specific system IP address. So you have option to grab a particular information. If I expand OMP routes further, then this is a way we can take a look what are the attributes comes and what are the details we can see while verifying some of the output on the devices. So on the Colo 2 VH1, if I run a command show OMP route 10.224.2.0/26 detail, while knowing this is the route which is coming from branch 3. So I see there are 4 entry comes, which we verified earlier as well. Let's take a look on the first entry. So the first entry, it is telling you the OMP route entries for the BPN10. And the reason behind this route is part of VPN10 while advertising from the branch end. The next thing, it is being received from the vSmart, which is the IP address 1.110.52. This is the lowest one that we know. The second vSmart is going to be 53. It's a path ID. This is a label. This route is installed in the routing table. And if I take a look on the attributes, it is telling you the attributes, the originator, this is coming from a system IP address 81, which we know as a branch 3 VH1. Type is installed. Now it is telling you, though it is coming from the system IP address, but my TLOC attachment is MPLS and my encryption type is IPsec. My site ID is 3000. Tag is set to 3000. Preference is not set. That is what we have verified earlier as well. Origin protocol is connected. So this route is a connected interface on the remote VH. AS path not set. Metric is 0. And now let's take a look on another entry. This is a continuation of the command received from 52, and this is the peer 52, my path ID 20, my label is 1003. This route is also installed. The only difference we are going to see, the TLOC attachment is different. Earlier we have seen it was MPLS, now we see it's a public internet with encryption type IPsec. Rest of the field remains same. This is further continuation of the same command. Now we see there are 2 more entry comes from the vSmart, which is going to be the 53, 53, and those routes are going to be received. Those are the valid route, but it is not going to get installed. So I see the status CR, both the places. The rest of the entries are going to be the same. I get 2 attachment. One is a MPLS and another one is a public internet with the encryption IPsec. Let's do some verification. So this is a diagram which we can see, and the route we were verifying is 10.224.2.0/26. 0/26, and that is exactly what we have received on the colo side. And this is a branch 3 VH1. So if I run a command show OMP route received from system ID, which is 81, which belongs to this VH, I can see the same thing. This is a route which is received from two vSmarts. One vSmart is going to install it, and there are two T-locks. I can also run a command show OMP route and give the exact route. I'm also going to see the same thing. That's a quick verification you can do for a particular route. After building the OMP vroute table, those route has to come to your data plane. So let's verify the data plane. If I run a command show IP route with the same remote subnet address, this is what I see. I only see two entries. These routes are learned from OMP. My VPN segment is 10. My prefix is /26. I get it from two different attachment with the encryption IPsec, and my status is FS. F means it's a part of the FIB, and it is selected. Thank you everyone for watching. I will see you in the next video.